Hello everyone, welcome to Ramaile Padai. Today we are going to learn a lesson about triangles and quadrilaterals, that is lesson 10 of class 10 mathematics, and from this chapter we will get a question that is about 3 to 4 marks in SEE. So this is one of the important chapter, but it is quite confusing as well. So let me give you information or warning that you might get confused somewhere in this chapter, but I will try my best to make you understand the concept of these triangles and quadrilaterals. Okay, so let's move on to the lesson. First of all, we will learn the basics of how these shapes are named. Okay, the name of these shapes are based on Latin based numerical system where 1, 2, 3 and 4 are named as uni. 1 is uni, 2 is bi, 3 is tri and 4 is quadri. Okay, now here we have three sides, three lines. One is this line, second is this line and third is this line. Okay, we have three edges as well. So this is first edge, this is second edge and this is third edge, and we also have three angles. This is first angle, this is second angle and this is third angle. So we have three lines, or what we call sides, three edges and three angles. So 3 is tri, so this is called as triangle. Okay, so triangle is closed polygon with three straight sides, three vertices. Let me just correct myself, this is called vertices. Okay, vertices is this point, this is vertex, this is vertex, this is vertex. Okay, and three angles. So we have three angles and the sum is always equals to 180. So the sum of internal angle of triangle is always equals to 180 degree. Okay, so this is triangle. Now what this should be, we have 1, 2, 3 and 4 sides. Okay, straight sides. We have 1, 2, 3, 4 vertices and we have 1, 2, 3 and 4 angles. So based on this system we will name this as quadrilateral. Okay, so this is quadrilateral. Here you the definition is that closed polygon with four straight sides, four vertices or corners and four interior angles that sum to 360 degrees. So the sum of interior angle of quadrilaterals is equals to 360 degree. Fine. Now then what is this? This also have 1, 2, 3, 4 vertices, 1, 2, 3, 4 angles and 1, 2, 3, 4 straight sides. This should also be quadrilateral, but the quadrilateral which have equal sides, opposite sides. Okay, so this side and this side is equals to equal, which is denominated by this single line. So that means that this side are straight, equal, and this double line means that these two sides are equal. And for parallelogram there also need to be parallel lines. Okay, so this two line represent that these two lines are parallel and this single arrow represent that these two lines are parallel. Okay, so the definition of parallelogram is quadrilateral that is characterized by having two pair of parallel opposite sides that are equal in length. Okay, so these opposite pairs must be parallel and equal in length, and this is called as parallelogram. Okay, so this is about the basic of these shapes. Now we will move on to calculating the area, learning the formula to calculate the area of this triangle and parallelogram. Okay, so we will first learn how to calculate the area of triangle. So for that we will need to understand what base and height is. So here base is this. Okay, so this is base of this triangle. Base is the length where it lies, okay, where the object lies, where the figure lies. So this is base and this is height. Okay, so the area of triangle based on base and height is area is equals to half multiplied base into height. Okay, this is the area of triangle. Now let's move on to parallelogram. For that, what we know is parallelogram must have two parallel lines that are equal in length. Okay, so this is parallelogram. Here you can see that this arrow and this arrow means that these two red lines are parallel, and this double arrow means that this opposite two black lines are also parallel. And let me give you this. This means that this length is equal to this length. Okay, and let me give double line here. This means that two black lines are equal as well. Okay, so this is parallelogram. Here we have this is base and the height is this. Okay, we always measure height on perpendicular angle, 90-degree angle. Okay, here you can see this is perpendicular angle. So this is height of the parallelogram, and the area of parallelogram is base into height. Okay, but do you know the relation between area of triangles, area of parallelograms between the same bases and between same in the same bases and between same lines, same parallel lines? So for that we need to understand some another principles as well. Here this triangle has equal height and equal base, but we don't know what is the relation between area of this triangle, blue triangle, and area of the parallelogram. So for that we will need to learn theorem. We have three theorem in this chapter. Let us uncover that theorem. Okay, so the first theorem is about parallelograms that standing on the same base and lying between the same parallel lines are equal in area. Okay, this says that two parallelograms that are standing on the same base and lying between same parallel lines are equal in area. So let us first construct a parallel line AB and CD. Okay, in these parallel lines we will construct a parallelogram PQRS. Here PQ is equals to RS in length and PS is equals to QR in length. Okay, let me just write it as well, symbolize, represent it as well. So this is parallelogram, PQRS is a parallelogram, and we also need to construct another parallelogram that is standing on the same base PQ and lying between same parallel lines, that is AB and CD. Okay, so the another parallelogram is this, the green one. So PQTU is also a parallelogram. Okay, and this green line, length of green line is also the length of UT is also equals to PQ, because here the opposite side of parallelogram must be equal. Okay, and this is equals to this. Okay, this is two parallelograms. Here in understanding theorem we will write what is given and what is needed to be proved. Okay, so here what is given is parallelogram PQUT, PQ, oh sorry, RT, sorry, no, PQUT, it is good, PQUT is good. Let's not be confused, guys. I got a little confused here. Okay, so the parallelogram PQUT, PQTU, it needs to be TU. Okay, PQTU. Okay, PQTU. You cannot write PQUT. Okay, and PQRS are standing on the same base PQ. Clearly see that, and lying between same parallel lines PQ and UR. You can also write AB and CD as well. Okay, the parallel lines. Now what is need to be proved is that area of parallelogram PQTU is equals to area of parallelogram PQRS. Okay, now we will solve this. I have mentioned it on the table, and I will explain this table to you. Here we will first consider two triangles, triangle PSU and triangle QRT. PSU, this triangle PSU, this triangle, and another triangle QRT. So this triangle, we will consider these two triangles. Okay, here PSU, angle PSU is equals to angle QRT. PSU, this angle is equals to angle QRT. This angle, you can say why? Because this is corresponding angle. Here you have these two lines are parallel. This is P, this is Q, this is R, and this is S. Okay, so the corresponding angles are equal. So angle PSU and angle QRT are equal. Okay, corresponding angle being PS parallel QR. PS parallel QR. Okay, that is PS parallel QR. Okay, now let's move on to second statement. Angle SUP. So this angle is equals to angle RTQ. So this angle. Here again you can see that the two parallel lines made corresponding angle. These two corresponding angle. Let me just write the name as well. PU and QT. These are parallel lines, and these make angle by a straight line. So these are corresponding angle. This is also equals to this is also equal. Okay, and another is PS is equals to QR in length, because this is opposite sides of parallelogram PQRS. Okay, so this is PQRS parallelogram, and we have said that this length is equals to this length. Okay, so here this is angle, and this is side. So this is AS axiom that we will write in second number. So triangle PSU is congruent to triangle QRT because of AS axiom. You might already know the concept about axiom. If you don't know, please let me know, and I will explain in a new video as well. Okay, here the area of the triangle that is congruent is equal. So area of triangle PSU is equals to area of triangle QRT. So PSU is equals to QRT in area. Okay, now we will add this PQTS. So this area, we will add this area to both equal area triangle. Okay, so adding PQTS to PSU and PQTS to QRT, adding trapezium on the both sides. So the this adding PSU to PQTS becomes parallelogram PQTU, and adding PQTS to triangle QRT becomes angle parallelogram PQRS. So the area of two parallelograms standing on the same base PQ and between two parallel lines AB and CD are equal in area. So this is proved. So you will need to write this. I have just explained the concept. You either need to memorize or you need to be creative and write it on your paper. Okay, so the basic principle about theorem is that you need to at least write 10 times without looking on the paper to memorize it. So this is quite difficult as well. You need a more practice. Okay, so here this theorem proves that two parallelograms standing on the same base and between same parallel lines are equal in area. Okay, so area of this parallelogram equals to area of this parallelogram. Okay, this is the theorem number 1. Let's move on to theorem number 2. Here theorem number 2 states that the area of triangle is half, that is 1/2 of the area of parallelogram standing on the same base and lying between same parallels. Okay, so first of all we will need to construct the same parallel lines. So AB and CD are parallel lines, and here PQRS is a parallelogram. Okay, now we will construct a triangle where the base of triangle is PQ. So PQU is another triangle, and what we need to prove is that area of a triangle PQU is equals to half the area of PQRS parallelogram. Okay, so this is given. So parallelogram and triangle are given, and to be proved is that area of triangle PQU is equals to half the area of parallelogram PQRS, and we need to construct in this. So we will construct PU parallel to QT. So we will construct a line QT that is parallel to PU. So this is the line. Okay. Now PQTU is also a parallelogram. Okay. Now we will prove that the area of triangle is half the area of parallelogram. So the first statement is that area of parallelogram PQRS is equals to area of parallelogram PQTU. Why? Because they are standing on the same base PQ and between the same parallel lines AB and CD. Okay. So the area of these two parallelograms are equal. Okay. You visualize it in your mind. Okay. So these are two parallelograms. Now the area of triangle PQU is equals to half the area of triangle PQTU. Why? Okay, so this area is half the area of parallelogram PQTU. Why? Because it is divided by diagonal QU into half area. So this area, let me construct this by this area is equals to the lower area. Okay, the lower triangle is equals to upper triangle in area. So the lower triangle PQU is equals to half the area of parallelogram PQTU. Okay, this is the second statement. Here we have already written is that what we have already written is PQRS is equals to PQTU. So we will replace the PQTU from the second statement and write PQRS. Okay, because we can write PQRS and PQTU same because they have equal area. So from this, area of triangle PQU is equals to half the area of parallelogram PQRS. So this is about the solution of theorem 2, and we have proved the theorem 2, which states that the area of triangle is half the area of parallelogram standing on the same base and between same parallel lines. You always need to memorize the two figures are standing on the same base and between parallel lines. Okay, so here we proved the theorem 2, where area of triangle is equals to half area of parallelogram. Okay, so this is about theorem 2. Now let's move on to theorem number 3. Here the area of triangle, so we have triangles, more than one triangle standing on the same base and lying between the same parallel lines are equal. So the two triangles are area equal in area. So let us first construct the parallel line AB and CD, and then construct first triangle PQR, and then construct another triangle that has base PQ and between the parallel lines AB and CD. So this is another triangle PQU. So now what we need to prove is that the area of PQU is equals to area of PQR. Okay, so here given is that triangle PQR and PQU standing on the same base PQ and lying between same parallel lines PQ and UR. Now what we need to prove is that area of PQU is equals to area of PQR. Okay, the green area is equals to black area. Okay, now for that we will need to construct PS parallel to QR so that PQRS become parallelogram. So this will be the construction. Okay, so PQRS is a parallelogram here. Listen, PQRS is a parallelogram. PQR and S is a parallelogram. Now we will prove this. So first of all, what we will write is that triangle area of triangle PQR is equals to half the area of PQRS. Why? Because this diagonal PR divide the area of parallelogram equally into two triangles. So upper triangle and lower triangle are equal in area. Okay, so this is our first statement. Second statement is that area of PQU is equals to half area of parallelogram PQRS. Why? Because in theorem 2 we have studied or proved that the area of triangle is half the area of parallelogram standing on the same base and parallel lines. Here the PQ is the same base and AB and CD are the parallel lines. So area of PQU is half the area of PQRS. So now we will take this part of the two statements because the right part is same for two statements. Okay, so now taking the left part of two statements, area of triangle PQR is equals to area of triangle PQU. So from statement 1 and 2, here the area of triangle is standing on the same base and the same parallel lines are equal in area. So this is about the theorem number 3, what we have proved. Okay, Now these are all the theorems that we need to learn. Now move on to the another problem that is quite difficult and what you have seen in your books. Okay, now I will try my best to explain this problem to you. So here in the given figure, PQRS, PQR and S is a parallelogram in which S is joined with any point O. So S is joined with any point O of side QR. Okay, so any point of O, S is joined with O on any side, any point of side QR. Okay, SO and PQ are produced up to point T, so SO is extended to T. Then prove that area of triangle PQO, this is the area, is equals to area of triangle RTO. So this is RTO. So we need to prove this. Okay, so now we need to construct something. We need to diagonally bisect this PQRS parallelogram. Okay, now this is what it is. Now let's move on to the solution. Okay, so construction. So given is this to be proved, I have already said, and construction is that we need to construct P up to R diagonally bisecting parallelogram PQRS. Okay, this will be the construction. So first statement I am going to write is that taking SR as base and two parallel lines PT and SR, the area of triangle PRS is equals to area of triangle TRS. Why? Because both lies on same base RS and between parallels PT parallel SR. Okay, this is the first statement. These triangle are equal. Let me visualize you by drawing the triangles here. Okay, so this is two triangle. Yeah, this is S and this is R, this is T and this is P. So the figure is quite another. So this SR and PT are parallel lines. So we have started in theorem number 3. Okay, that the area of two triangles standing on the same base and between two same parallels are equal in area. Okay, so this is first statement, and the second statement is that the area of triangle PQR is equals to area of triangle PRS. Why? Because line PR bisects parallelogram PQRS. So this area is equal. Okay, you need to write area of in front of every triangle. Okay, area of. So this is two statement. Now I'm going to write the third statement as well, and the third statement will be what? Let me think of it. Okay, let me think. Okay, two parallels, fine. Okay, now here we will write triangle POR is equals to triangle area of triangle POR is equals to area of triangle ORS. Why? The reason is simple, because both lies on same base OR and between two parallels PS parallel QR. Okay, so this is the reason. Now what we will do is combine the equation statement 1 and 2. So from the statement 4 will be triangle PQR is equals to triangle TRS. Okay, because TRS is equals to PRS and PQR is also equals to PRS. So from statement 1 and 2. Okay, so this is it. Now PQR is equals to TRS. Now we will subtract this equation 4, equation 3 from equation 4. Now subtracting PQR, POR. Okay, so triangle PQ, area of triangle PQR minus area of triangle POR is equals to area of triangle TRS minus area of triangle ORS. Okay, so this ORS is subtracting from TRS. So the reason will be subtracting statement 3 from statement 4. Okay, so now what is remaining is that PQR minus POR, so that is triangle PQO, and if you subtract ORS from TRS, then we will get triangle RTO. Okay, so from statement 4. So this is about how we will prove this question. This is one of the toughest question in the exam and in this chapter. So if you have understood this, it is not hard for you to understand this chapter. So this is about the solution of this and concept of this chapter, and we will meet you in the solution of triangle and quadrilaterals in the coming video. Till then, the video has become so long and I want to say goodbye from this video. We will meet in the next video. Till then, bye bye.